Using the formulas we derived earlier, we can create a chart that will help us in the application of these formulas to real-world problems. So, if you're given a hydronium concentration of 10 to the negative fifth, and you already know the Kw, which equals 14, you can find the pH, the pOH, and the hydroxide concentration. Alright. Okay. So if the hydronium concentration is 10 to the negative 5, you know that the pH is 5 because the hydronium concentration equals 10 to the negative pH. So you know that the pH is 5. If the pH is 5, you can subtract 5 from 14 because pH plus pOH equals 14. So 14 minus 5 equals 9, which is then the pOH. So the OH concentration, you can now surmise to be negative 9 because the hydroxide concentration equals 10 to the negative pOH. So let's try a harder example. Say you're given a pH of 4.07. From this, you can say that the hydronium concentration equals 10 to the negative 4.07. We can take the formula for the equilibrium of water, which is pH plus pOH, and substitute the unknown, which is pOH, in for x. So if we have 14 equals 4.07 plus x, we can subtract the 4.07 from the 14, which gives us x equaling 9.93. Okay. So the pOH, we can say equals 9.93, which makes the OH equal 10 to the negative 9.93. So now you've discovered the pH, which you started out with, which is 4.07. You have the hydronium concentration, which is 10 to the negative 4.07. And you have the pOH, which is 9.93. And the OH, which is 10 to the negative 9.93. And then the equilibrium of water. Because you can't leave your hydronium and hydroxide concentrations in decimal form, you have to go on your calculator and... Don't go to my calculator. Oh, okay. And from this, you can get 8.5 times 10 to the negative 5. Ooh, my battery. 9.93. And then you get 1.2 times 10 to the negative 10.